Hi, and welcome to the Patterns of Earth and Sky unit launch video. My name is Julie, and I'm a 5th grade science teacher in Chicago, Illinois, and I cannot wait to tell you about this awesome unit. This unit centers around the phenomena of a new artifact that was found with a missing piece. Students work throughout the unit to discover what might be on that missing piece. Before we begin, make sure that you've read and annotated the unit at a glance and the science background knowledge documents. Then have your unit internalization guide and a pencil ready to get started. In this unit, students will work to discover that the patterns on the artifact represent the things that we see in the sky. Students act as astronomers and work with the Museum of Archaeology through a variety of emails. Through their investigations, students make sense of the images on the artifact by exploring distances and brightness of stars, how the Earth moves, and why we see different things in the sky at different times of the year. At the end, students will make predictions of what constellation might be on the missing piece based on patterns from investigations. Before we get started, why does this unit matter? This unit, first of all, matters because outer space is awesome. Learning how the Earth fits into the greater picture of our universe is not only important, but it's fascinating and enduring. Learning about the Earth and stars ignites curiosity and pushes the boundaries of understanding and exploration. It helps students comprehend the vastness of the universe and our place amongst the stars. We're going to start going through some of the lessons in each of the chapters. For Chapter 1, students are answering the question, why don't we see a lot of stars in the daytime? They explore the distance of stars in our universe and why the sun appears so big and bright in the sky. In Lesson 1.1, students are introduced to the artifact and to the mystery of discovering what is on the missing piece. The artifact carries through all the chapters in the unit. In Lesson 1.2, students find evidence for the spherical shape of the Earth and are first introduced to the patterns of Earth and sky simulation. Students begin to think about where the stars are in space. In Lesson 1.3, students read an awesome book called How Big is Big, How Far is Far. This book introduces students to a few big ideas. Students use visualizing techniques to think about the relative size and distance of things in space. Students begin to see that the size and distance is relative and that objects, like the Earth or Sun, can be both small and big or close and far when compared to different objects. In Lesson 1.4, students complete an investigation on the sim to find distances to stars in the Great Square of Pegasus. Through a class modeling activity, students will be able to discover that stars are very far away in all directions. They also find that the sun is a star in our solar system and it's the closest star to Earth. In Lesson 1.5, students investigate the question, if the stars are all around us, why can't we always see them? They answer this question using the sim and a class model and discover that the stars that are closer to Earth, like the sun, appear bigger in the sky. They find that the sun is not the biggest star, it's just the closest star to Earth. Stars that are very far away appear smaller in the sky. In Lesson 1.6, students continue to investigate why we can't always see other stars in the sky. They do this by watching a video about distance and brightness and discover that stars that are closer to Earth, like the sun, appear brighter in the sky. Stars that are far away from Earth do not appear as bright, even though they could actually be brighter stars. They also gather evidence to prove that other stars are always in the sky, but the sun's brightness overwhelms the light from other stars during the day. Finally, in Lesson 1.7, students are introduced to the process of writing scientific explanations and how to include evidence to support our ideas. This lesson culminates with their first chapter focus task. The first chapter builds toward Progress Build 1. This states that the sun looks bigger and brighter than all other stars because it is much closer to Earth than all other stars. In the Chapter 1 focus task, students will be writing an argument about why we cannot see stars in the daytime. They will also analyze diagrams and data to explain why the sun appears much brighter than other stars. At this point, you should have the Chapter 1 focus task pulled up in front of you. Before you try the questions on your own, I just want to point out some key parts of the tasks. First, the writing tasks provide a mastery checklist for students. They also provide a word bank of vocabulary words. Students are required to include evidence, so to help students remember what we have used in class, there's a page in each of the chapter tasks with possible sources of evidence from each chapter. Now, pause the video and try the questions on your own. Attached to the rubric, you can find the exemplar responses. You can see that the evidence that students choose to answer the question may vary, but they must include evidence. Take a minute to pause and read through the exemplars now. Chapter 2 introduces the question, why is the sun up sometimes but not other times? Lesson 2.1 introduces students to the new chapter question. Students are also introduced to the Mount Nose classroom model, where they imagine what they would see in the sky when their heads are Earth and they are standing on their nose to demonstrate how the Earth's spin relates to the pattern of when we see the sun and when we see other stars. In Lesson 2.2, students use the sim to investigate different times that constellations are visible in the sky. Then they reflect on the process of investigation by evaluating a sample investigation. After Lesson 2.2, you'll notice in your unit at a glance that there is also an optional master teacher created lesson on shadows that has students do an investigation about size and direction of shadows based on the sun's location in the sky. Lesson 2.3 uses diagrams and videos to help students explain that the daily pattern of when we see the sun and other stars is due to the Earth's spin or rotation. They also complete a modeling tool where they think about what different people in different places will see in the sky. Lesson 2.3 also has an optional flex tension that has students make shadow clocks to understand the daily changes in length and direction of shadows. Lesson 2.4 has students investigate the question, if the Earth is spinning, which way is up? Students gather evidence through a video about how things fall and a book, Which Way is Up? They find that up is away from the Earth and down is toward the center of the Earth anywhere on Earth. In Lesson 2.5, students complete modeling tools to show what people on Earth would see in the sky and which way is up for them. They also complete a modeling activity called spinning globes, where we think about what is up and what is down at different places on Earth. They find that people see different things when they look up, even though up is still away from the Earth. In Lesson 2.6, students will work with their partners to write and evaluate scientific explanations. Students also take the Chapter 2 focus task. Chapter 2 builds toward Progress Build 2 that states that, as the Earth spins, what we see in the sky changes throughout the day. At this point, take a minute to pull up the Chapter 2 focus task. You can find this linked from the unit at a glance. The Chapter 2 focus task has students analyze a diagram to explain what would have to happen for the person in the diagram to experience nighttime. The second and third parts have students write about which way is up and how gravity pulls things toward the center of the Earth. Pause here and take some time to try this chapter task on your own. Here is the exemplar for Part 1. Note that the evidence will vary. Take a minute to read through the Part 1 exemplar. Part 2 shows that all arrows should be pointing away from the Earth. Finally, take a minute to read through Part 3 and the exemplar response. In Chapter 3, students begin to investigate why we see different stars and constellations in the sky at different times of the year. They will investigate Earth's orbit to show that Earth's position in its orbit determines what stars we see. In Lesson 3.1, students do an investigation on the sim to discover that we see the same constellations in the sky on the same date each year. They see that there is a yearly pattern of when we see the same stars in the sky. In Lesson 3.2, students create constellation posters that coincide with the constellations in the system view of the sim and then hang them around the classroom. They then add to the Mount Nose model by orbiting around the classroom to see that different stars can be seen at different times of the year based on where Earth is located. In Lesson 3.3, students investigate the two movements of Earth, rotation and orbit, and do an investigation on the sim to show the connection between time of year, Earth's location in its orbit, and the stars that we see. In Lesson 3.4, Students read the book Dog Days of Summer and work together to place Sirius, the dog star, in our classroom model based on when it's visible in the sky. In Lesson 3.5, students will use evidence from the Handbook of Stars and Constellations to identify the constellations on the artifact. They will then complete the Chapter 3 focus task. As you can see in the unit at a glance, Lesson 3.6 has actually been moved after Chapter 4 and includes the Chapter 4 focus task. The reason it's moved is because the task actually has students identify the missing piece of the artifact based on patterns and data, and it answers the overall unit question. We will go over this lesson while looking at Chapter 4. The third chapter builds to Progress Build 3, which states that as Earth orbits the Sun, the stars we see in the night sky change throughout the year. Now, pull up the Chapter 3 focus task. Like the others, this task has a few parts. Students will be creating a diagram based on data and will then write an argument that includes evidence from their diagram and from class. Students will also be writing an argument using data to explain when we see different constellations in the sky. Pause now to take the Chapter 3 focus task. Take a minute to read through the exemplar response for Part 1. Pause and take a minute to read through the exemplar for Part 2. Finally, take a minute to read through the exemplar for Part 3. In Chapter 4, students are investigating the question, how can we investigate why we see different stars on different nights? In Lesson 4.1, students read a book called Star Scientist that talks about an astronomy investigation. They use this text to begin to plan their own astronomy investigations that they will complete over the next 2 lessons. In Lesson 4.2, students begin to draft, share, and revise their own systematic investigations that they will execute in the following lesson. Finally, in Lesson 4.3, students will use the sim to complete their investigations. They will gather data and then have an opportunity to share and revise their plans. Like we mentioned, Lesson 3.6 was moved after Chapter 4 in the unit at a glance. This lesson has students identify the constellation on the missing piece of the artifact using evidence from our unit and from the sim. Students will then complete the Chapter 4 focus task. Pause and open up the Chapter 4 focus task now. This task brings us back to our big unit question. In the Chapter 4 task, students will make a prediction about what constellation appears on the missing piece by identifying patterns and data. They will then write an argument about the constellations using evidence from the artifact and from class. Pause and take a minute to complete the Chapter 4 focus task now. Here are the exemplars for Chapter 4 focus task. Pause and take a minute to read them over. We're now going to look at a few of the questions from the end of unit assessment. You will have a chance to answer one from each progress build and a constructed response as we go. Let's get started. Here is a progress build 1 question. Pause and try to answer it now. The correct answer to this question is C. If Sam walks 15 steps backward with the softball will appear smaller to the class because it's now farther away. Let's try a progress build 2 question. Press pause now. The answer to this question is C. Students should be able to connect that the dig site is facing away from the sun, so it is nighttime there and the museum should not call them. Pause and try one of the progress build 3 questions. The answer to this question is C. Students should know that there is a yearly pattern of when we see the constellations. We see the same constellations in the sky at the same times every year. Finally, try a constructed response question. Pause to write your claim with evidence and reasoning. Take a second to read over the exemplar and compare it to your response. Thank you so much for reviewing this unit and preparing to teach your kiddos. You are going to find that your students get ridiculously excited about identifying the missing piece. I can't wait for you to see the joy that this unit brings to students. Finally, if you're a KIPP teacher, there are a few last steps for you to complete. Good luck and have a great year.